laude. And this means he had essentially a straight A average, and that was before grade inflation, of course. Anyway, it's interesting to note he did not originally intend to be a physicist. When he enrolled at Harvard, he said he wanted to be a mining engineer. But his letters during his early years at Harvard, and those letters are accumulated as a book by Smith, which I referred to, they strongly suggest he was interested in becoming a writer. He continually offered his friends copies of stories and poetry he had written. But nevertheless, he graduated from Harvard as a chemistry major. But by the time he graduated, he had decided to become a physicist, an experimentalist, not a theorist. In fact, he began his graduate studies doing experimentally work under J.J. Thomson, but he wasn't particularly successful at that. He was not happy or successful. And eventually he decided to be a theoretical physicist, and he somehow found his way to Göttingen, where he received his Ph.D. in 1927 as a student of Max Born. Now, once he began to do research in theoretical physics, his productivity was astonishing. He published 4 papers in 1926, when he was only 22 years old, and he published 5 papers in 1927. And he began his actual career as a physics professor in 1929 with a joint appointment at Caltech and at the Berkeley campus of the University of California. But after a few years, he taught at Caltech only in the summer, while he spent the remaining months of the academic year at Berkeley. And he functioned as a full-time academic. He taught courses and directed graduate students until the closing months of 1941, when, definitely before Pearl Harbor, I want to stress this, he began working on problems related to nuclear weapons. In early 1943, he went to Los Alamos as laboratory director, and everyone agrees. Now, I was not at Los Alamos. I was one of the few of the students who didn't go, but I was not there. But everybody agrees he was an absolutely outstanding director. In 1945, after the bomb had been dropped and the war ended, he returned to his professorship at Berkeley for 2 years, and then he left to become director of the Institute for Advanced Study in Princeton, which was his last employment. Now, although he'd been a prolific researcher before the war, he essentially ceased personally doing research once he went to Los Alamos. That's not surprising. He had no publications between 42 and 45. But he published actually only 4 papers in all with collaborators after 1945. His last published research paper was 1950. Now, during the years 1945 to 54, he was, I would say, a folk hero. He was one of the government's principal advisors, if not the principal advisor, on nuclear weapons policies. But in 1954, the Atomic Energy Commission stripped him of his security clearance after a very widely publicized hearing wherein he was accused of associating with communists. So this ended his role as a government advisor. And to his very great distress, as generally agreed. Now, I want to mention here the fact, which is not too well known, that during his hearing, and the transcript of the hearing has been published in book form. It's 1,000 pages or so in very small type, and I list this book on the list there. So if you want to read, want to get a picture of government paranoia during the United States McCarthy era, you can read it. And I also list a rather recently published book by Wolverton, which discusses the hearing's unfairness to Oppenheimer and also his life after the hearing, which that was the last time he was a governmental advisor. Now, Raymond Burge, who chaired the Berkeley Physics Department during Oppenheimer's tenure, has written that Oppenheimer was very absent-minded. Now, I myself never saw the slightest evidence of any absent-mindedness in Oppenheimer, and quite the contrary, and it's hard to believe that anybody who was a successful director of Los Alamos could have been absent-minded, but Burge has some evidence on his side. So let me show you the evidence. One evening, Oppenheimer was then still unmarried. He drove his former student, Melba Phillips, up into the Berkeley hills, presumably to pitch a little woo, You say she had already earned a Ph.D., so we can't accuse Oppenheimer of unprofessional conduct. Anyway, this is from the Oakland Tribune, February 14th, 1934. And let me read you for those of you who can't, right underneath the forgetful Professor Park's girl takes self home, the title for the most absent-minded professor in the world goes without question to J. Robert Oppenheimer, 30, physics prof at the University of California. And what happened, apparently, is that after some time, he excused himself, had to attend to a call of nature, and then he just walked home. He just forgot about her. And she stayed there. She didn't know what to do, and finally, one of the park policemen came through, and she told him about it, and he looked for him, couldn't find him, and then they called where he was living, and sure enough, he was home and asleep. So this story, I got this when I got to Berkeley, because this graduate student was still giggling about it. And so I got a copy of this, which I've retained. All right. Now, my own personal recollections of Oppenheimer, which I'll now turn, are confined to the period from August 38 to January 1942, when essentially I got my degree. I'm not going to go here into the reasons why I didn't get to go to work with him on the Manhattan Project, but I didn't. Now, I went to Berkeley to work with Oppenheimer at the suggestion of Mark Zemansky, who was the author of a pretty well acclaimed physics textbook on thermodynamics. And he was my favorite instructor at New York City College, where I did my undergraduate studies. What happened was I asked Zemansky where I should go to graduate school, and he just answered, without hesitation. He recommended Oppenheimer's group in Berkeley. And since my most pressing desire at the time was to get as far away from home as possible, and here he was in California, there was no question. Now, when I arrived in Berkeley, I knew really nothing about Oppenheimer beyond his name. But I immediately became acquainted with him via the introductory quantum mechanics course he gave. And that was in my first semester at Berkeley. And then I took his electromagnetic theory course in my second semester. And in succeeding years, I took his course in advanced quantum mechanics and in field theory courses. And now, in my experience, his courses were always well taught. He was always well prepared, and I want to say this for some of you, that was in marked contrast to Nobel laureate Ernest Lawrence, who for an entire semester floundered through a course on electrostatics, despite the fact that he was a cyclotron guy. But now, one problem with Oppenheimer was he lectured very fast, and I mean very, very fast. So all I was able to do was take as many notes as possible, and then you had to work your way through those notes right away where you still remembered them. And I learned a lot, and I had to work very hard. Now, although he lectured at a prodigious clip, he would take questions, and he generally would answer them patiently, unless the question was manifestly stupid, in which event he was likely to be quite caustic. But he also was impatient. He would, in a sense that he'd give patient answers, and then if they didn't work, he'd get caustic again. And my analysis of this is that if he had a fault, his fault was that he lacked empathy. I don't think he had the gift of really putting himself in another person's place. He didn't understand, for instance, how a student was reacting to what he was saying. And as I said, a student who persisted after receiving his initially patient answer, he could expect to find himself on the receiving end of quite sarcastic remarks, and Oppenheimer could be very sarcastic and cruelly caustic. Now, what I haven't mentioned yet, the most distinctive feature of his lectures was chain smoking. He spoke quite rapidly, but he smoked equally rapidly. When one cigarette burned down to a fragment he no longer could hold, he extinguished it and he lit another, almost in a single motion. And that's what he did. And I can still visualize him, and I mean this seriously. His characteristic blackboard pose was one hand grasping a piece of chalk, the other hand dangling a cigarette, and his head wreathed in a cloud of smoke. And so, it's no surprise that he died in 1967 at the age of 62. And I'll leave it up to you to discuss or to think about whether the fact that I'm here today is evidence that the health risks of secondhand smoke have been overrated. All right, now let me tell you about, I just told you about my classroom recollections of Oppenheimer. They're actually considerably less vivid than the recollections stemming from my attendance at his weekly theoretical physics seminar that he ran. I joined his group, and that means his students and his research associate, who now would be called Oppenheimer's postdoc. In roughly the spring of 1939. Now, joining this group was not a formal procedure. As I recall, I told him I was interested in working with him, and he said, okay, we'll see what you could do. And he told me, he didn't give me a research problem, but he told me he expected me to attend his seminar. And so that's what I started doing. And all I did was just go to that seminar like all the other students in this group once a week. And also, one of the things I learned from attending a seminar, he didn't mind being called Oppie. And in fact, as I say, although he could be fearsome, he really didn't put on airs. And so I fell into the habit of thinking about him as Oppie. I mean, student called him Oppie, and I'll call him Oppie probably in this talk, for the remainder of this talk. Now, the number of students in this group deserves special mention. He joined the Berkeley faculty in the fall of 1929. He remained at Berkeley until the summer of 42. He was given a leave of absence to work on you know what. Now, of the 24 students who earned their PhDs under his supervision during this 13-year period, 16 received their degrees between 1939 and 1943. And actually, I recall that every one of those 16 already was a fellow graduate student of mine by the fall of 1940 when I had published my first paper. So, recognizing there were a few, not many, but a few students of Oppies who never received their PhDs, the facts I've just recited imply during every one of the years I was in Berkeley, Oppie was a PhD thesis advisor of between 15 and 20 students, of whom a large fraction eventually earned their PhD degrees. Now, that's a remarkable statistic. I mean, I think even in the most halcyon days of the United States Physics Department since the World War II, theorists flocking all over, I doubt there have been more than a handful of professors who at any one time supervised as many ultimately successful theoretical physics students as Oppie did. And a good many of his PhDs went on to distinguished careers. The category includes Willis Land, Philip Morrison, David Bohm, and others. I'm listing only the names that I know you'll all recognize. So now, returning to Oppie's seminar. Its regular attendees were his students, his research associate, Oppie himself, but there were other more or less regular attendees during my years at Berkeley. Of these, the most noteworthy was Professor Felix Bloch from Stanford. He was just about Oppie's age, and once a month or so would drive in from Palo Alto with a few of his students. And that was before, when I got to Berkeley, that was before the day of the Bay Bridge, so that was really quite a long drive. Had to go away. Now, the seminar itself was Oppie's domain. It was his fiefdom. His behavior in the seminar displayed the same lack of empathy he displayed in his teaching. He rarely gave a talk himself. I mean that. He preferred instead to sit in the front row, and he interrupted the speaker with questions, no matter who they were, and without any consideration to how they seemed to react to questioning. Now, I well remember that several times he reduced Leonard Schiff, who was Oppie's research associate during most of the time I was there. He reduced Schiff almost to tears. And, you know, as a result, Oppie's students, including me, held no real appreciation of Schiff's talents. Certainly, we didn't expect that Schiff would have a distinguished career, including being a member of the National Academy and chair of the Stanford Physics Department. And another habit of Oppie's in this seminar was to answer somebody else's question before the speaker could answer it. Or, not infrequently, he would jump up and take over the blackboard while the speaker still was in the middle of his talk. Now, Felix Bloch frequently suffered these rude treatments. And the students in Oppie's group, took notice of Bloch's willingness to accept such treatment, and we were fond of saying that Bloch was Oppe's most advanced student. And I remember how surprised I was to discover, well after I received my Ph.D. and had left Berkeley, that Bloch was a famous physicist in his own right, and he later received a Nobel Prize. Now, Oppe reportedly continued his domination of seminars at the Institute for Advanced Study. Jeremy Bernstein writes in his Oppenheimer biography that when Dyson came to the Institute to talk about his work, showing the identity of the Schwinger and Feynman formulations of QED, before the work had been published and claimed, and I'm quoting now from Bernstein's book, Dyson got the treatment. He was scheduled to give 5 lectures, but in the first 2, Oppenheimer would not let him talk. He reduced him to silence. And apparently it was only after receiving a very stern letter from Beta that Oppe restrained himself and allowed Dyson to actually describe his work. And, I don't have to tell you that in general, speakers don't like to have somebody in the audience take over their role. I wouldn't like it if Alex came up. So I think what I should tell you again, that to me, again, it illustrates his lack of empathy. He thought he could do better than whoever else was there at the board, and he took over with no idea how irritating his behavior was. He was not taking advantage of the fact that it was his seminar. And as evidence for this belief of mine, let me read you what Max Born, who was a 1954 Nobel laureate for work in quantum mechanics and his statistical interpretation of the wave function, I'm quoting, what Max Born had to say about Oppe's behavior in Max Born's seminar when Oppe still was Born's graduate student. And as you listen to what I'm about to read to you, remember that Born, who won the Nobel Prize, is writing about pre-World War II Germany, where a student was expected to worshipfully revere his house professor. Now I'm reading, quoting from Born. This quotation is from Jeremy Bernstein book. Oppenheimer was a man of great talent. Now these are Born's words. Oppenheimer was a man of great talent. He was conscious of his superiority in a way which was embarrassing and led to trouble. In my ordinary seminar on quantum mechanics, he used to interrupt the speaker, whoever it was, not excluding myself, and to step to the backboard, taking the chalk, and declaring, this can be done much better in the following manner. I felt the other members did not like these personal interruptions and corrections. And after a while, they complained. But this is Born speaking, remember, I was a little afraid of Oppenheimer. And my half-hearted attempts to stop him were unsuccessful. At last, I received a written appeal. They, the students, gave me a sheet of paper looking like parchment in the style of a medieval document, containing the threat that they would boycott the seminar unless the interruptions were stopped. I did not know what to do. At last, I decided to put the document on my desk in such a way that Oppenheimer could not help seeing it when he came to discuss the progress of his thesis with me. This plot worked. That was Born. Okay, so really this concludes just about all I want to say about Oppenheimer. I mean, he's enduringly famous, and I'm sure all of you know that very recently an opera has been written named Dr. Atomic, in which he is the principal character. So, I will now turn to Julian Schwinger, unless somebody has any questions or wants to ask me something. All right, I will now turn to Julian Schwinger. Now, this is a picture of Julian. It was taken a number of years after he was at Berkeley, but he looked just about the same. One was at Harvard. And one of the reasons I've been devoting time to Schwinger in this talk is that although he did win a Nobel Prize and he died in 1994 at the age of 76, and he really was a genius, as I will elaborate, his name is sort of been forgotten by the public and even by graduate students, in contrast with Feynman, whose name remains well known to a good part of the public. And so, that's really, since I knew Schwinger well, one of the motivations I had, one of the things that prompted me to do this. So, let me illustrate what I'm talking about there. This is it's a portion of a panel, a top portion of a panel, one of a set of panels produced by the APS in 1999 for celebrating the 100th year of the Physical Review. And it was distributed to most university physics departments. I know we have it's posted at Pitt, and in most places, I imagine it's posted here at Harvard somewhere. Now, please note, I'm confident about all of you, even if you can't read the small print in the slide, that you recognize that's a photo of Feynman. And let me read you a portion of what the text to the left of the photo says. It says, together with American colleagues and Japanese physicists who had worked along similar lines while they were out of touch with the West during the war, Feynman, in caps, solved the problem by creating quantum electrodynamics, QED. And now the question I ask is, where is Schwinger's photo? And even, where is Schwinger's name? I mean, this is a panel officially created by the APS, who should know better. They certainly should know that Feynman shared with Schwinger the 1965 Nobel Prize. And in fact, Schwinger performed the calculations which explained the two leading QED experiments, the Lamb shift and the value of the electromagnetic anomalous magnetic moment, before Feynman did. Now it's true, if you look carefully on the slide, on this panel, in a portion of the panel which is not shown here, there's a small box in the middle of the panel, about the size of one of those boxes there, which does mention Schwinger, but it can't be found. You certainly didn't get his picture. And so, as I say, that was sort of indicative. Now, actually, in terms of ages, both Schwinger and Feynman were about the same age. They were both born in 1918, when I was born. But Schwinger began to publish far ahead of Feynman, and he was much more famous than Feynman until about 1955. And in fact, here's what Feynman himself had to say about his first meeting with Julian when they both were 25 years old. And this I'm reading now from something Feynman wrote. It was not until I went to Los Alamos that I got a chance to meet Schwinger. He had already had a great reputation because he had done so much work. I was very anxious to see what this man was like. I'd always thought he was older than I was because he had already done so much more. At the time, I hadn't done anything. And he came and gave us lectures. I believe they were on nuclear physics. I'm not sure exactly the subject. But it was a scene you probably all have seen once. The beauty of one of his lectures. He comes in with his head a little bit to one side. He comes in like a bull into the ring, and he puts his notebook down and begins. And the beautiful organized way of putting one idea after the other. Everything very clear from the beginning to the end. I was supposed to be a good lecturer, according to some people, but this was really a masterpiece. So I was very impressed, and at times I got them to talk to him. I learned a lot. Okay, that was Feynman talking about Julian. Now let me give you a brief summary of Schwinger's life and career as I did with Oppie. Like Oppie, and Feynman for that matter, Schwinger was born and brought up in New York. And again, like Oppie, he was very precocious and he soaked up information. But he manifested his precocity and his absorbed information very differently from Oppie. In particular, he very early became focused on physics. And he learned physics essentially completely on his own, with little or no help from the formal educational system. He began this self-education at a very young age, primarily by reading books in the public library, and he carried it on so effectively that by age 16, when he graduated from high school, he was already doing publishable calculations. And also by this time, he already established his habit of working through the night, about which more later. Now, his close friend, physicist David Saxon, brought him to UCLA at the close of his career. According to Schwinger's close friend, Schwinger once remarked that he began reading through the Encyclopedia Britannica at a very early age. When he came to the letter P, that was it. Now, Schwinger himself, in the autobiographical material submitted to the Nobel Foundation, indicated, "The principal direction of my life was fixed at an early age by an intense awareness of physics, and its study became an all-engrossing activity." Now, Sylvan Schweber's book on the development of QED, which I list on my Schwinger sources sheet, and it was in the audience today, by the way, he tells the following story about Schwinger's precocity, and I quote, "Apparently Schwinger's high school physics teacher, Irving Lowen, who at the time was trying to complete a theoretical physics Ph.D. thesis at New York University, had come across this kid in quotes, sitting in the library reading the physical review, in fact reading a paper by Dirac. So Lowen thought, well, here's another one of those smart aleck kids that we get every once in a while. So Lowen quizzed him about what he had been reading, and Schwinger allegedly was not only capable of telling him what he was reading, he also told him what needed to be done to complete what Dirac had not completed in this particular paper." Now, the story may be apocryphal, but it does seem to be the case that Lowen was so impressed that he introduced Schwinger to his Ph.D. professor, Otto Halpern, in the New York NYU Physics Department, and Schwinger began working with Halpern, and that culminated in Schwinger's first published paper with Halpern in the 1935 Physical Review, when Schwinger was 17 years old. And Schwinger also, through Lowen and Halpern, became known to a number of other physicists in the New York City area, with whom and for whom he began doing calculations. And thus, as Schweber puts it, Schwinger's precocity and genius made him a living legend even while in high school. Now, I first met Julian in 1934, shortly after he entered CCNY. We met when we both took intermediate mechanics, which was the first course in physics after elementary physics. Now, I had not heard of him before. I didn't know him. But everybody but the course instructor was somebody named Shea. We immediately recognized Julian as another species. You know, most of us had just learned how to take vector products. And Schwinger would perform manipulations like making integrals vanish using the divergence theorem. Very impressive. Now, I want you to recognize that at the time, CCNY had the most outstanding student body in the US. Really, there's no doubt about it. But the faculty, they just didn't even come close to matching up. So anyway, this brings me to except for my age, which is, my main claim to fame. At the end of the semester, I got an A and Julian only got a B. Right. Now, why did Julian only get a B? He only got a B because he didn't come to class, he worked at night, but he came to class to take the exams, and Shea disliked him because he could do the exams, so he gave him only a B. Now, I do want you to understand at the time, the CCNY curriculum had a huge, and I mean huge, number of required courses outside the major. I took 4 semesters of public speaking. You can see to hear how they work. A semester of Asian history, a semester of modern history, a semester of economics, 4 semesters of English lit, a year of chemistry, a year of biology, a year of engineering drafting, and so on and so on. Well, Julian hardly ever came to class, as I explained. He could pass the exams in math and physics. He could not pass the exams in these courses without attending. And so by the summer of 1935, Schwinger was essentially flunking out of CCNY, and this is absolutely true. This disaster, fortunately, came about just when his paper with Halpern, The Polarization of Electrons by Double Scattering, was published. And he also was in the process of completing a second paper, which is titled On the Beta Radioactivity of Neutrons, which was written with Lloyd Motz and published in the 35 Physical Review. Now, Motz was an instructor at CCNY, and at the same time, he was a PhD student of Robbie's at Columbia. And he brought Schwinger to the attention of Robbie in the following way. And now I'm quoting from something that Robbie has written. Here. There was this paper of Einstein, wrote Podolsky, and Rosen. And I was reading it. And one of my ways of trying to understand something was to call in a student and explain it to him and then argue about it. And in this case, this was Lloyd Motz, who was also at that time, I think, an instructor or something at City College. And then Motz said there was somebody waiting for him outside. So I said, call him in. So he called him in, and there was a young boy there. So I asked him to sit down, we continued, and then at one point there was a bit of an impasse, and this kid spoke up and used the completeness theorem to settle the argument. And I was startled. What's this? What's this? So then I wanted to talk to him, which I did, and it turned out I was told he was having difficulty at City College. Now, I knew the people he was having difficulty with. It's an honorable thing to have difficulty with those people. So I suggested transferring to Columbia. And then I got a transcript from City College, and I took it to one of the officials, I forget who it was. Now, what about a scholarship for this guy? He looked at the transcript and he said, on the basis of this, we wouldn't even admit him. So I then said something very tactless, I suppose. I said, suppose you were a football player. Still the problem remained. But I overrode him, and he was admitted. And that's actually what happened. If it weren't for Robbie, I don't know what would have happened to Julian. But he was admitted to Columbia. He was permitted to take whatever courses he liked. He got his BS, his Bachelor of Science degree in '36, by which time he already had done enough work to warrant a Ph.D. He continued his research as a student of Robbie's until he actually was awarded his Ph.D. in '39 at age 21. And so once he got to Columbia and was free from the City College constraints, his creativity burst forth. He had no publications in '36, but here's a list of the papers he published in 1937. These are Schwinger's papers. All the papers are non-trivial and some quite important. The fourth paper with Teller, pointed out that scattering from ortho and parahydrogen could be used to disentangle the low-energy singlet and triplet neutron proton scattering amplitudes, which is really quite important. The first paper is Julian's solo flight. In it, he corrects an expression for the magnetic scattering of neutrons derived by Bloch. And Julian had no hesitation about stating in print that Bloch had made a mistake, although he was 19 years old, and Bloch, of course, was a professor at Stanford. And Julian was right, because, as it happens, the paper was refereed by Hans Bethe, and Hans Bethe emphasized that Julian was right. And I remind you, all these publications, they were accomplished by Julian on his own. He was self-taught, essentially on his own, because he wasn't attending his classes, he wasn't taking exams anywhere, except to take exams. Now, he came to Berkeley in the fall of '39 after receiving his Ph.D. He replaced Schiff as Oppe's research associate. Now, essentially, all the students in Oppe's group knew nothing about Schwing, essentially, except me, maybe one other. And they were all eagerly anticipating Julian's first seminar. They were wondering how long it would take Julian to shrivel under Oppe's question. I, on the other hand, I was wondering how Oppenheimer would react when Julian wouldn't shrivel. And indeed, his first seminar went exactly as I anticipated. Oppe asked Julian a question, Julian answered, and he asked him another question, he answered, and he asked him another question, with hardly breathing, he answered 9 or 10 questions, and then Oppe never interrupted him after that. Now, Robbie relates that Oppe initially was terribly disappointed with Schwinger. He disliked Julian's habit of working at night, and he came into the seminars, but he really was not around the way Oppe was used to having shift around all the time. And apparently he even had thought of asking Julian to go elsewhere. But he learned to respect Julian soon, and in fact they wrote 2 papers together. Now, when Julian arrived in Berkeley, mine, of course, was one of the very few faces he recognized. As I said, we were about the same age, so we became good friends, really. Much better friends than we had at City College. And although he did all the teaching of physics between us, I taught him a few things. For instance, I taught him to play pool, which he'd never had tried previously. And about a year after he arrived at Berkeley, we started working together on a problem which eventually became one of the publications that constituted my Ph.D. thesis. I'll tell you about this problem a little later, but first I want to tell you what working with Julian was like. See, I had to accommodate to his schedule. So there were some days when Julian got up early enough to get into Berkeley at LeConte Hall at a reasonable time. He came to the seminar, whatever it was. But on most days, here was my life in the year or so I spent working on this problem. At 11:45 p.m., I met Julian at Berkeley International House, which was maintained by Berkeley, where he was staying. And so he picked me up, and we drive to an all-night bistro that Julian had found where he had breakfast. Then we went back to LeConte Hall for 3 hours of work, and then we went to some other bistro where he had lunch. Then we went back to LeConte Hall and worked till 8 a.m. when I had to leave to attend courses and be a TA, and I'd gotten married that year, so I had to do certain husbandly duties. Julian went and had dinner somewhere, and then he went to sleep. And I don't remember how I got through this year. It was just a blur, but I did. Now, this now brings me to another illustration of Schwinger's awesome talents, which was personally observed by me. Oppie had two students who came about a year after I did, their names were Bernard Peters and Chaim Richman. And they, one day, I should have said, Oppie had an office in which he allowed his students to go in. The reason, he had books which are not available in the library. He had a book by Kramers, for example, on quantum mechanics, which was very useful. And he was very nice about this. You could just come into the office and use those books and so on. You didn't have to lock. Well, one day, one afternoon, about 5 p.m., I was in the office, and Julian was there that day, and Oppie was there, and in came Richman and Peters, and they told Oppie they'd like to work on a problem together. And so Oppie thought a little bit, and he said, why don't you do the electron disintegration of the deuteron? And he explained to them the idea. The idea was, here's an electron, no nuclear forces, but nonetheless, the electron comes back rapidly by, as an electric field gets concentrated. Just the electric field is enough to pull the proton away from the deuteron, away from the neutron and disintegrate the deuteron. What's the cross-section for that? That's what they had to work out. So, okay. Well, that evening, that same evening, I went to pick up Julian at 11:45 p.m., my usual time. And there was Julian sitting downstairs at a Western Union desk. In those days, we still had Western Union. He was sitting down there at the Western Union desk, and he's scribbling away on these Western Union telegram sheets in the back of them. And I said, what are you doing, Julian? He said, oh, that was an interesting problem. I'll be finished. And so he scribbles a little bit more, and he takes the sheet of paper and he just puts it in his desk. He said, let's go out. So we went out to breakfast and so on. And I thought no more of it. 6 months later, as it happens, I was in Oppie's office again. Oppie was there. Julian was there. In come Peters and Richman beaming. They have the cross-section. They've done it. So Oppie says, let's see it. And so they write on the board. You see it's pretty long, so they write on from one end of the board to the other. They write down this formula. And Oppie looks at it, and he says, looks like it could be all right. The dependence, the energy is what I thought. And then he says to Julian, didn't you tell me you had worked this out? And Julian starts looking, and he finally fishes out of his pocket here this crumpled piece of Western. This is true. And he smooths it out. He looks at it. He looks at the board. He looks at it. He says, it looks right, he says, but they're missing a factor of 2. And Oppie, without hesitation, he says to them, find that factor of 2. So, you know, when they came in beaming, they slump out. And about 3 months later, they reported they found the factor of 2. Whether they actually did or not, I don't know. And the paper was published, and that was the end of it. But what happened was that both Richmond and Peters became experimentalists. Now, I suffered, but I somehow or other did not become an experimentalist in my reaction with Julian. So let me tell you about my own research with Julian. You know, when Robbie made his unexpected discovery that the deuteron had a quadrupole moment, Schwinger realized immediately, and was certainly the first to do this, that this fact implied that the nuclear two-body interaction had to include non-central, so-called tensor forces. And he described this conclusion actually in a 10-minute paper delivered at an APS meeting in 1939. And what this meant was that all the previous two-nucleon system calculations that had been carried out by Bright and his co-workers, you know, grinding away, they had all ignored the tensor force, and therefore they had to be essentially revised. And what Julian wanted to discover, to ascertain, was whether velocity-independent local potentials could account for all the properties of the two-nucleon system, not just, you know, the quadrupole moment. Now, at about that time, a man named Rarita, who had been, he was a professor, I think he was a social professor at Brooklyn College, had come to Berkeley on a sabbatical. He typically took a sabbatical every 7 years and went somewhere to work and come to Berkeley. And he had heard of Schwinger because he had been in New York. And so he got together with Schwinger, and Schwinger had him work on the problem of seeing whether the same tensor forces, which seemed to give the quadrupole moment of the deuteron correctly, would also explain various other facts about the known two-nucleon system. I mean, scattering, various problems like that. And so, Rarita was working away at this, and by the time I got started with Julian, or sort of a little after that, it became pretty apparent to Julian that yes, it was going to work, that the two-nucleon system forces that he had got, that they really would explain all the properties of the two-nucleon system, not merely the deuteron problem. And so actually Julian sort of lost some interest in it, and the problem he had put to me, the problem I was worked on, was whether or not the same forces, the same potential, would work for the three-nucleon system. In other words, for hydrogen-3 and helium-3 and even the alpha particle. That's what I was looking at. Could I explain the binding energies of hydrogen-3 and helium-3 and the alpha particle using the same potential? So that's what I worked on. Now, let me now show you. So I began, so this involved calculating a lot of doing a lot of spin sums. I mean, this is a typical matrix element, which I've written down here. There were about 100 or 120 matrix elements at that time which had to be evaluated. And what went on is that, you know, you had to do these spin sums, and you had to do the angular integrations correctly, and then we had a spatially part of potential, had a square wave, or we had and then that part had to be done manually. I mean, on the only computers available at that time were a Marchand or a Monroe, and so I was banging away at the Marchand and Monroe, and I was doing that while in the next room there was Rarita banging away in his part of the calculation. That's what was going on. But now, as I said, before you got to the numerical calculation part, you had to do the spin sums and the angular integrations. And there were about 100 to 120 such matrix elements. And so Julian and I agreed that what we would do We would do those independently, and then we'd compare the results, and then if they didn't agree, I mean, we'd do them together on the board, and if they were right, then I'd go ahead and do them. So, of those 100 to 120 or so, as I recall, we disagreed maybe, say, 15. And we did them on the board, and not once was I right. Julian was right every time. And you know, I was furious about it. You know, I'm sort of furious now. You know? I mean, I'm not bad. I mean, I'm really not a bad theorist. Not once did he make a mistake. It was just so infuriating. So that's what happened. And so I did them, and that was it. And then after I did this, as a matter of fact, he left. He left Berkeley in about, oh, let's see, around June or July of 1941. He went to get a job. He got his first academic job, which was at Purdue. He was an instructor at Purdue. In those days, that was the best academic job he could get, to be an instructor at Purdue. And in fact, Julian did not like to write up his stuff. And I wrote up the paper, and I sent him a copy, and I said, I'm going to send it in if you have comments, if I don't hear from you in a month. And so he sent me some comments, and we sent it, and it was published. Rarita couldn't do this. He just didn't know it. And so, during this period, and especially toward the end, because he had a sabbatical, and that's coming toward June, you know, his sabbatical was going to be over, he kept asking Julian, can you write up the paper you written? And Julian would say, yeah, I'll write it up. Well, Julian really got, and one night, and again, this is all true, fellas, we came in together, you know, from lunch or something. Rarita was already there working, and when Rarita heard us, he came out, and he just muscled. He was the same. Julian was about 5'6", and Rarita was too. Rarita was much broader, really, and he just muscled Julian to the wall. Got him against the wall, and he said to Julian, if you don't get that paper finished, I'm going to kill you. In 3 weeks, the famous Rarita pair of papers were written. Fairly famous papers. I'm not kidding. That's what happened. And Rarita went home happy and got promoted. All right. Well, let me say that once the writing of my paper was finished and Julian went off to Purdue, I never worked closely with him again, but we remained good friends. And I always spent time with him whenever he saw him. And he worked at the Rad Lab during World War II. And he later told me that Opie had wanted him to come to Los Alamos, but he didn't want to. He felt that Opie would try to dominate him. And in fact, he told me later that Opie had wanted him to come to Berkeley, and you know, he actually, after the war, he was offered a job at Harvard, which he took, but that Opie had wanted to come to Berkeley, and he would have loved to come to Berkeley. He loved Berkeley, and that if he had known, as apparently Opie really already knew by that time, that was planning to go to the Institute, he would have taken that job at Berkeley. He was really very angry with Opie, that Opie had not told him this, and that's why he went to Harvard. Anyway, in 1945, he got a job. He took a job as associate professor at Harvard, and in 1947, he was promoted to full professor at Harvard at age 29. But at that time, it was certainly a record. And that certainly began the happiest period of Julian's life. I have to finish this up pretty fast. During which he did the work that earned him the Nobel Prize. He gave his famous series of courses on special topics in theoretical physics, many of which contained all sorts of new results that he never bothered to publish. But the course notes, some of those were written up and published by Schwinger's students. And for instance, Schwinger nuclear physics lectures were written up by John Blatt, and Hermann Feshbach has written that these lecture notes form an excellent introduction to the applications of quantum mechanics, developing a number of elegant methods of wide applicability. They contain many results specifically important for nuclear physics, many of which were never published or were later rediscovered. It's difficult to exaggerate the impact of these letters on the generation of physics graduate students in the late 40s and 50s. For example, the effect of radiant expansion was derived in one of his 1947 lectures, but only published by Schwinger in 1950 after Bader published his derivation. So listen, I don't want to take more time. I will quote again from Schwinger on Schwinger's lamp shift calculations. He says, the notes of Schwinger's calculations are extant. They give proof of his awesome computational powers. Starting from the Hamiltonian for the coupled field system, the self-energy terms were identified, a mass renormalization was then performed. What previously had been pieces of a theory became welded and unified into a consistent, coherent quantum electrodynamics to order alpha, the fine structure constant, and so on. These calculations were carried out fearlessly, seemingly effortlessly, often involved steps were carried out mentally, and the answer was written down. And most important, the lengthy calculations are error-free. All right, now a few years after this, Feynman's methods began to become current, and Schwinger's dominance over theoretical physics calculations began to ebb. He was no longer the hero he had been. Oppie, by the way, Schweber quotes Oppie saying, most people solve a problem to show it can be done. Schwinger solves a problem to show that only he can do it. All right, and then, toward the close of Schwinger's life, he went off on source theory, which is an attempt to formulate QED in such problems in a way that avoided infinities and renormalization. It was not a path that other people have followed, a few have, and anyway, and so he slowly was no longer in the forefront of theoretical physics. And I should also say, and I'll close with this, that many physicists, including me, think his most enduring achievements may be his students. And I pointed out Oppie had 24 students who earned PhDs in 13 years. At Harvard, Julian had 68 students who earned their PhDs in 27 years. That's almost 50% greater than the rate of Oppie's. And these PhDs included a remarkable number of famous physicists. 4 of his students were Nobel laureates: Ben Michelson, Shelley Glashow, Walter Kohn, a Nobel laureate in chemistry, and Roy Glauber recently. And others were Kenneth Case, Ken Case, Lowell Brown, Bryce DeWitt, Abraham Klein, Mertzbacher, and so on. And so, Saxon wrote in his Schwinger obituary that even if explicitly mentioning Schwinger's name no longer is fashionable, these PhD students produced by Schwinger, who utterly dwarf Feynman's corresponding production in both number and reputation, they may outlast the impact of both Feynman's and Schwinger's actual publications. And I'll close with that. Yes, I'm happy to have some questions.
Questions?
Yes?
Why do you suppose that someone as intelligent as Schwinger supported cold fusion to the bitter end?
That is an aberration. It may have been an attempt by Julian to recapture some of the fame which he thought was eluding him. And for some of you, let me say that Julian published some papers which essentially, hazarded some mechanisms which could have explained how it was possible for cold fusion to take place and no neutrons to come out, which was the trouble with the experimental work on cold fusion. They claimed fusion was taking place when we were the neutrons. And Julian somehow or other said that. Well, anyway, he was serious about this, and I can tell you again, this is something, I was involved with the AAAS at the time, and they were talking about having one of these symposia on cold fusion, and Julian was supposed to be one of the speakers actually. Well, it never came off. But, so he did take cold fusion seriously. I do not know why. It was an aberration. It was toward the end of his life.
I have a theory, which is that he realized that it didn't violate any of the main concepts.
Can't hear you.
It realized that cold fusion did not violate any of the big conservation laws.
No, that's true.
It was a question of ingenuity.
Yeah, but it was clear that without neutrons, I mean, how could it be a nuclear reaction? That's the point. Yeah. No other questions?
No other questions? Yes.
Did he continue to be a night owl after he became a Harvard professor?
Yes. Did he work at night?
Did he continue to work all night?
Yes. He did. I think the answer is yes. He went into his classes. He made his classes. By the way, that was something else. You know, Abraham Klein has written. He wrote a memoir of a sort about his, being a student with Julian. His students really liked him. It was very difficult for them to get to see him. He was protected. Julian's wife protected him like anything. In the biography of Schwinger is noted, she's quoted as saying that she didn't realize until later what a compliment Julian paid her by having his first date with her at 3 p.m. in the afternoon. So the students found it hard they didn't come in and had a sort of line up outside, but then once they got to see him, he was very patient, and one of the things Klein says is that if you put a Feynman diagram on the board, Julian would sort of wince, but he wouldn't say anything and let you go on with it.
Can you describe what your PhD exam was like?
Well, yes, I certainly will. I obtained my PhD. I was working, and Pearl Harbor came on a Sunday. It was a Sunday. And Monday, I went into the control, and I saw Oppenheimer. And Oppenheimer said to me, "You've done enough work. You're going to get your PhD." And at the time, I had 2 papers published, one in press and Physical Review. The one with Julian was in press. And so what I did was I put together those 3 papers in what was called a thesis, some problems in quantum mechanics. And I had a perfunctory oral, and I mean it, And so 2 weeks later, I essentially had my PhD. I didn't get it awarded formally until 1942. But that's when my troubles, if you must know the story, the sad story of my life, that's when my troubles began. Because, and I'll tell you that. See, Oppie had asked me to work with him on this group of people who had started in about the summer of 1941, working on nuclear, and I didn't want to do it. I didn't want to work in weapons research. I mean, of course I did later in the war, but I didn't want to. And so, anyway, when I got my PhD, about a couple of weeks later, R.T. Burge, the chairman of the department, called me in, and he said to me, "Well, now that you have your PhD, I can't give you a TA, because you have your PhD." So there I was, and my $65 a month was suddenly gone, which I was living on. And so I actually asked Oppenheimer then, and he didn't want me to work. And he said, "With your attitude, I don't want you." And so I was stuck. And so that's how I ended up in underwater sound after quite a lot of tribulation. But he went on, and other students went on to go to Los Alamos. But I never really had much of an oral or anything like that. Yeah.
Could you say something about the politics at Berkeley while you were there?
Yes, well, let me say, okay. He's asked me if I'd say something about politics at Berkeley. Let me say, first of all, I had come to Berkeley from City College. City College was as radical a place as you could imagine, and I was pretty radical. I don't mind telling you again, all out of told the FBI this. I was a member of the Young Communist League while I was at City College. And I was not really active. Some people worked in a branch of the YCL, which was at City College. I worked in a branch near my home. I was more prudent than that. But I had sort of, how shall I put it, I had become disillusioned before I even got to Berkeley. And in fact, since we're all asking here, you want the story of my life, I had been expelled from the branch in Brooklyn for laughing at meetings. It was a formal trial. It was a formal trial, and I was expelled. This was, of course, because they're having these expulsion trials in Russia at the same time, and we're following it. Anyway, so when I got to Berkeley, I felt that Oppenheimer and most of the people I saw there were rather politically rather naive. Now, I had made up my mind I wasn't getting involved. I mean, I was really going to work. I worked hard, and I did. As I said, I was a pretty good student. I felt Oppenheimer was politically naive. There were people there who were not. Morrison was certainly not naive. Other students of Oppenheimer were. But I, of course, personally, did not really know the people whom Oppenheimer went around with, who supposedly had all these communist associations for which he lost his clearance. Now, there was no doubt about the fact that he was, and I found out later. I mean, Frank Oppenheimer was certainly, he may have been a member of the Communist Party. His wife was certainly very, very radical. And the woman whom Oppenheimer married, she had been very much involved with radical people, and she had a friend named Nelson, who was a really prominent communist when it came out. And Oppenheimer had a girlfriend before he got married named Jean Tatlock, whom I knew about as it happened because my wife had a very, very good friend who was a very, very good friend of Jean Tatlock. So I sort of knew about that association even while I was still a graduate student and didn't talk about it. But, and Jean Tatlock was communist. But in the actual, among the graduate students, except for my conversations with Morrison and so on, not much went on. Now, on the other hand, the faculty, it was clear the faculty was pretty reactionary. Lawrence was very reactionary. There were some other people there who were reactionary, and we did get it with that. So that's the best answer I can give you. Yeah.
Do you have impressions of David Bohm?
Well, David Bohm came to Berkeley actually 2 years after I did, so he was really low down. I did not know Bohm very well. Bohm, things happened at Berkeley. There was also Joe Weinberg was at Berkeley. Joe Weinberg I'd known in City College. He got to Berkeley after I did. He had worked for a while with Bright. They couldn't get along with him. And then had come to Berkeley. And Bohm once told the woman I married that he, Weinberg, was 10 times as smart as I was, and that Bohm was 10 times as smart as Weinberg was, and the conclusion was she shouldn't marry me. But anyway, so I didn't know Bohm very well, and it was a surprise to me. His book was really a very nice book, which I used after when I taught quantum mechanics in the textbook. Now, he got into trouble. You see, the war came along, and that's when the trouble began. What happened was that when Oppenheimer went to Los Alamos, he left behind a few students of his who were supposed to work with Lawrence. They had various, and there was all this idea of having calutrons to make uranium-235, and so those students, and one of them was Weinberg, and one of them was Dave Bohm, and there was another student, and they had some idea of making of unionizing the rad lab, and that caused, Oppenheimer. Lawrence was furious, of course, and that's why they all got into trouble, and they were threatened with being drafted. One of them did get drafted, and that was how their trouble started. And Weinberg got to be followed around, and the stories are supposedly that Weinberg was seen talking to a member of the Soviet embassy in San Francisco, and that's how he became Scientist X. And so that's what took place. I don't know if that answers.
Well, they were interesting times. Anyone else? Well, let's thank Ellen very much.